Good morning, friends. Myself Shankar Vanose. Today we are going to see one of the important bit of integral calculus, that is gamma function. Okay, let's start with the definition first. For n is greater than 0, the value of the integral over 0 to infinity e raised to minus x raised to n minus 1 dx is called gamma function, and it can be written as gamma n. Notations I have written there. Gamma n is equal to integral over 0 to infinity e raised to minus x raised to n minus 1 dx. Remember, n should be greater than 0, positive number. Okay, next we will see some properties of a gamma function. Gamma 1, we can write it as n minus 1 into gamma of n minus 1. Okay, comma, where that n should be the positive fraction or positive number, we can say. Second, gamma n is equal to n minus 1 factorial. Particularly if n is a positive integer number is there, then we can write it as n minus 1 factorial. Hope that you are understanding. Gamma n minus 1 of gamma n minus 1, if it is a rational number, we can say in the form of fraction, p by q, 2 by 3, 5 by 8 by 3, in this form, then we can write 8 by 3 minus 1 into gamma of 8 by 3 minus 1. Okay, in this way we can simplify the gamma function. And second and third properties, the value of gamma half, particular number is given there. Half value of gamma function will be root pi. Its value is root pi. Its proof will be seen at the time of beta function. Second, gamma 0 is equal to infinity. Gamma of positive integer always exists. Remember, gamma of positive integer exists by the definition, but gamma of the negative integer is infinity. That means gamma of minus 1, gamma of minus 2, gamma of minus 3, gamma of minus 4 is equal to infinity. With gamma 0 is also infinity. Okay, these are the some properties of gamma function. Okay, next let's see the examples of a gamma function. Okay, there are total four types of example are there in gamma function. Let's discuss the first type 1, that is integral over 0 to infinity e raised to minus ax raised to n dx is equal to, its value of the integral is 1 upon n a raised to 1 by n gamma of 1 by n. Which value? If our integral is of the form 0 to infinity e raised to minus ax raised to n dx, then just we have to compare the values of a and n and put the values of a and n in RHS. That will be the answer, or that will be the value of the integral. Okay, next let's consider example of type 1, 0 to infinity e raised to minus x square dx. Clearly by observation we can say that it is of example type 1, e raised to minus x square. Okay, how to solve the example? Let I is equal to the integral 0 to infinity e raised to minus x square dx. Okay, give an example. Clearly it is in the form e raised to minus ax raised to n. First write down the result as it is. Next, comparing with the result, compare e minus minus a is equal to 1, the coefficient of x, and n is equal to power of x, that is 2. Put all these values in the result: 1 upon 2, 1 raised to 1 by 2, and gamma half. As we know that gamma half is equal to root pi, and 1 raised to half, that is 1 raised to anything, again 1, and divided by 2. This is our answer, root pi by 2. Okay, let's consider a second example now. 0 to infinity 7 raised to minus 4x square dx. Now if we observe that, the example is not in the standard form, that is e raised to something is not there, there is a 7 raised to something, okay, but single term is there. That means limit is 0 to infinity and single term is there. That means it is example of type 1, we can say, just by observation we can say that. Let's suppose right on the first step, I is equal to our integral 0 to infinity 7 raised to minus 4x square dx. Okay, now we have to write this 7 raised to minus 4x square in the form of e raised to ax raised to n. Okay, how to write that? Consider that value y is equal to the given function, that is 7 raised to minus 4x square. Next step, taking log on both sides, log y is equal to minus 4x square log 7. Next, y is equal to e raised to minus 4 log 7 x square. Okay, taking anti-log on both sides, simply on LHS log get cancel, and for RHS it becomes e raised to, construct the constant terms before the variable x square, that is 4 log 7 into x square. Now we can say that, we can observe that the function has been converted in the form of e raised to ax raised to power. Okay, therefore I is equal to, put this value in the integral and comparing with the our result, what we get, the coefficient of x is 4 log 7, that is a is equal to 4 log 7, and power of x is 2, therefore n is equal to 2. Okay, next I is equal to 2 1 upon 2 4 log 7 raised to half, 1 upon n, a raised to 1 upon n, 1 upon n. Okay, root pi, that is 1 upon 2 4 log 7, which is equal to, we can take square root of 4 outside the outside the root, it becomes 2, already 2 is there, 2 into 2 4 under root log 7 root pi is the value. Okay, next we will move further for type 2, that is integral of 0 to infinity x raised to m e raised to minus x raised to n dx is equal to, value of the integral again 1 upon n into a raised to m plus 1 upon n, m plus 1 upon n. Just m, x raised to m is additional present there, and the change in the result will a raised to m plus 1 comes, and in the gamma function also m plus 1 upon n. That is a simple change. Difference is x raised to m is additional in type 2. Okay, next consider type example, we will consider, evaluate first 0 to infinity e raised to minus 2x square x raised to 4 dx. That on the integral, that is clearly it is not the case of type 1, it is obviously type 2, because x raised to 4 is additional present there. Okay, comparing with the result, we can say that the value of suppose first we'll go with a is equal to exponential function x coefficient, that is 2, and power of x of that exponential, it is n, it is 2, and m is equal to 4, the power of single x, that is 4. Remember the comparison again, e, power of e is a and n, a coefficient of x, n power of x, and single x is there, of that x, m is equal to 4. Okay, I is equal to 1 upon 2. We will put the value 1 upon n. N is equal to 2. A is equal to 2 raised to m plus 1. M is 4. 4 plus 1 by 2. 4 plus 1 by 2. Just simplify the answer now. Here at the denominator 2 and the 2 raised to 5 by 2 bumps and gamma of 5 by 2. This is our answer, or we can simplify the answer as laws of indices we can use, and in denominator it becomes 2 raised to 7 by 2, and gamma 5 by 2, by the property of gamma function we can simplify that 3 by 2 into half into gamma of half. Okay, in the denominator it becomes 2 into 2 4, 2 raised to 7 by 2, and numerator 3 into gamma half is nothing but root pi. This is the example of type 2. Similarly, consider one more example, 0 to infinity e raised to minus root x into root x dx. Let I is equal to, we get a is equal to 1, n is equal to half, and m is equal to half. Again, it is in the case of the type 2 because two terms e raised to something and x single x. Again, comparison. First, we will compare a coefficient of x of exponential e, that is e, and that power of that x half, and m is equal to power of the single x, that is half. Put all these values 1 upon 2, 1 raised to 1 m plus 1 upon n, m plus 1 upon n. Clearly, in the denominator, in the first term 1 upon 2 is there, then by simplification 2 will get shifted to numerator, 2 into, now 1 raised to second term, 1 raised to anything is there, that will be 1, neglect that. Third term is half plus 1 upon 1 upon 2, 1 upon 2 shifted as a 2 into the bracket, 2 into 3 by 2, that 2 get cancelled, 3 remains only, therefore gamma 3 comes, and gamma 3 is nothing but 2 factorial, and 2 into 2 4 will be our answer. Okay, this is of type 2. Now let's go for type 3. Again, most easiest example. Type 3 is of a little bit different as we compare with our definition. For the definition, limits are 0 to infinity, but here the limits are 0 to 1. What is the type of integral? That is 0 to 1 x raised to m log x raised to n dx is equal to minus 1 raised to n m plus 1 raised to n plus 1 gamma of n plus 1. Okay, 0 to 1 x raised to 4 log x cube dx. Consider the first example. Easily we can, by observation we can say that it is of type 3 because limit is 0 to 1 and log x is present there. Okay, I is equal to 0 to 1 x raised to 4 log x cube dx. By with the comparison of the result, to compare the result we are supposed to be add every time the result in each example. That means my first step will be, we know that the result, and after that comparison will be there. Comparison with the result, power of a single x is m, therefore m is equal to 4, power of log x is equal to n, that is 3. Put all these values in the integral in the RHS, that is minus 1 raised to 3, 4 plus 1 raised to 3 plus 1 gamma of 3 plus 1. Okay, negative number minus 1 raised to odd power is always negative, therefore minus 1. 3 plus 1 means gamma 4, 4 plus 1 5, 5 raised to 4. Gamma 4 we can write it as a 3 factorial and negative sign as it is, 3 factorial upon 5 raised to 4. By using calculator we can find the value of 5 raised to 4. That will be our final answer. Okay, this is the easiest example of the type 3. Hope you are getting my point. Next we'll consider the second example. 0 to 1 root of log of 1 by x dx. Okay, I have written in the bracket there answer is always positive. Why I have written, I will explain later. Remember, if the example of is of log of 1 by x, then answer should be always positive. Okay, okay, I will explain why it is positive. Let's write on first our usual method. let I is equal to the integral 0 to 1 root of log of 1 by x dx. Our result is for log x, not for log of 1 by x. Therefore, we have to consider the log. Right, log 1 minus log x raised to half dx. 0 to 1. 0 minus log 1 value is 0 and log x is as it is minus log x raised to half. Okay, we have used log property, log of a by b, that is log 1 minus log x, log a minus log b, and the value of log 1 is equal to 0 and minus log x raised to half. Clearly again our result is for log x, not for minus log x. Therefore take minus raised to half common from that integral, that is minus 1 raised to half, take common, log x raised to half remains, but x raised to m not present there. Therefore we can treat x raised to 0, its value will be 1. Okay, just for adjustment for the integrand. Okay, now log x raised to half, x raised to 0 is there. Now comparing with the result, power of a single x is our m is equal to 0 and power of log x is n, that is half. Now minus half minus 1 raised to half is original already in the example, and next for result minus 1 raised to n is there, that is minus 1 raised to half, and 1 upon m is equal to 0 plus 1 raised to m half plus 1 and half plus 1. Okay, why it is positive? Minus 1 raised to half, minus 1 raised to half. If suppose minus 1 raised to n is there and another value minus 1 raised to n comes, that means minus 1 raised to 2n, and 2 into any integer always positive, always even power, and negative number raised to even power is always positive. Therefore the answer is always positive. Gamma 3 by 2 remains, that is half plus 1. It is 0 plus 1 means 1 raised to anything, again 1, and 3 by 2 we can write half into gamma half, that is root of pi by 2. Okay, hope you have understood log of 1 by x, log a by b first, that half is of that root. Okay, and similar way you can simplify the example and we will get the answer. Okay, the last type, that is type 4, integral of 0 to infinity x raised to a raised to x dx. Okay, answer is 1 upon log a raised to a plus 1 gamma of a plus 1, its direct value. Clearly it is the easiest example. Just we have to compare only one value, that is a, and clearly that is power of x is there and that constant raised to x is there. An example, consider one example, 0 to infinity x raised to 5 raised to x dx. Okay, I is equal to integral over 0 to infinity x raised to 5 raised to x dx. Comparing we get the constant as 5, that is a is equal to 5, put the value log 5, 1 upon log 5 raised to 5 plus 1 gamma 5 plus 1. Okay, 5 plus 1 means it is 6, gamma 6 upon log 5 raised to 6 is the answer, or we can simplify gamma 6 is equal to n minus 1 factorial, means 6 minus 1 factorial, that is 5 factorial upon log 5 raised to 6. Okay, this is the final answer. Okay, that much. These are the 4 types of example of a gamma function we have seen: type 1, type 2, type 3, type 4. Hope you have understood. Okay, now let's revise within 5 minutes what we have seen in this video lecture. We have seen the definition, we have seen gamma function and its examples. Gamma function definition, first we have seen gamma n is equal to 0 to infinity x raised to minus x raised to n minus 1 dx for n is greater than 0. Next we have seen the properties of gamma n. Gamma n is equal to n minus 1 gamma of n minus 1 of for a positive fraction. Gamma n is equal to n minus 1 factorial for integer, that is for numbers 4, 5, 6, 7, 11, 13, 14 integers, and gamma half is equal to root pi, its value. Gamma 0 and gamma of negative integer will not exist, it will be infinity. and gamma of always positive integer, positive numbers will exist. Examples type 1 we have seen 0 to infinity e raised to minus x raised to n dx, and the result just we have to compare the values of a and n. Exponential function x, coefficient and power of x, coefficient of x and power of x. Coefficient of x is a, power of x is n. Okay, next we have considered some examples and we have compared and we have solved. This one is important one. The second example, 7 raised to minus 4x square. The example not in the standard form, that is e raised to minus ax raised to n. We have to convert it. How to convert? Taking log on both side and taking again anti-log on both side, so that we get in the form e raised to minus 4 log 7 x square. Again comparing with the result, coefficient of x is 4 log 7, power of x is n, that is 2, and put the values, simplify, we'll get the answer. Second, the change in type 1, that is we have added x raised to m in the integral. X raised to m is added, that means the change in the result as 1 by n, as it is a raised to m plus 1 upon n, and gamma of that m plus 1 upon n multiplied by gamma of that m plus 1 upon n. Okay, consider example, e raised to 2 minus 2x square x raised to 4. Clearly now exponential function, coefficient of x is a and power of x is n. We have write 2 and power of a single x, that is m 4. Put all the values, simplify. Similarly we have seen one more example here, and x raised to m log x raised to n dx, result is minus 1 raised to n upon m plus 1 raised to n plus 1 gamma of n plus 1. Log, and clearly limits are 0 to 1 and log is there. Okay, comparing with again power of x is always we have considered m, and power of that log x we have to consider here n. Put the values and get the answer. This one is again important example, 0 to 1 log of in root of log of 1 by x dx. Answer always positive because I have explained. For this particular example we have to use the property of log, that is log of a by b, log a minus log b. Log 1 0, always it becomes 0. Similar we have to simplify. Again our result is for log x, not for minus log x. Take minus sign outside, minus 1 raised to the bracket power half it comes, and adjust x raised to 0 because our result contains x raised to m. X raised to 0 is equal to 1 as we know. Now compare and put the values. And the last type, 0 to infinity x raised to a raised to x dx, log a raised to a plus 1 upon a plus 1 into gamma of a plus 1. Compare the value of just a and put the value of a in the result. Okay, in this way we have completed our gamma function. Okay, thank you.